Good morning. Today we will review the most important property of logarithms. And before we do that, let's look at these couple of problems again based on what power function that we did earlier. So the first problem, it says log of 13. In parentheses we have 1, so we can call it as what power of 13 will give you 1. So you will change it to the exponent form, so you will have 13 as the base. We don't know the power, so we'll write x for that, and that is equal to 1. Now if you remember, any base, if it has an exponent of 0, that gives you a 1. So you can write this one as well in the form of 13 exponent 0. So once you do that, you have the same base, and when you have the same base, you can compare the exponents, the powers. So x will be equal to 0. So this was the first problem. And then the second problem we have is that what power of x will give you x squared? Okay, so now we will have x power, let's say this, since this is a different unknown, let's have it as y is equal to x squared. Okay, so what power of x will give you x squared? Okay, so this goes to this side, unknown exponent we come here, and then this becomes like this. So now you can see that y is equal to 2. So if we have an exponent of 2 for x, then we will have a value of x squared. So these were the problems. Now let's look at the key points. It says log of x without the b subscript means log of the base 10 and value x, called the common logarithm. So whenever you see a log without mention of any base, just understand that it is base 10, and that it's also called the common logarithm. All properties of logarithms come from the concept that logarithmic and exponential expressions are inverses. Both sets of expressions adhere to the same basic associations, which means multiplication is addition, and if we have division, that implies subtraction, and the operations undo each other. The third property is to use integer properties. It is helpful to decompose or break apart numbers. For example, log of 300 can also be expressed as log of 100 times 3, and then you can find out the value for log of 300. The most important property of base 10 logarithms is that positive real numbers x and y can be expressed. Log of xy is the same as log of x plus log of y. So when you take a logarithm of a number which is a product of two numbers, then it is the same as the log of each number, and you add them up. For positive real numbers, x log of 1 upon x is equal to negative log of x. Uh, So basically, this is, again, you can write 1 over x as log of 1, negative log of x, and log of 1 is 0, so it's going to be negative log of x. So anytime you have an expression in the denominator and you need to find its logarithm, it's the same as you have the negative value of the same thing in the uh, numerator, negative log of x. So the three properties are given down here. So if you have a number multiplied with 10 with an exponent, it's then 10, a base, and log cancel out. So you will have k plus log of x. Log of xy, where x and y multiply, is the same as log of x plus log of y. And log of 1 upon x is the same as negative log of x. Okay, so these are the few key points that I wanted to discuss before we go to today's teacher model. So let's look at the problems, and you should try to do these problems yourself, or just note down how I do it, and then you will do your own practice. Okay. So what we're going to do is we're going to use this property here, log of 10 exponent k times x equals k plus log of x, and we'll use this property as well as this table of some of the log values for a range of numbers from 1 to 9, and we'll compute these log of these numbers. So we start with log of 80. What I will do is simply I will write log of 80 as log of 8 times 10, and then I can split this as log of 8 plus log of 10 exponent 1, so it's going to be 1. So my answer will be log of 8, I can find out from here, 0.9031, and log of 10 is basically 1. So my answer will be 1.9031. So you can see that I didn't need to use a calculator to find out log of 80. I simply split that into 8 and 10 and solved it. The second part of example 1, we have log of 7,000, and we change that into log of 7 times 1,000. So in my next step, I can write this as log of 10 exponent 3 plus log of 7. Then 10 exponent 3, log and 10 base cancel each other, so I'll have 3, and log of 7 from here, 0.8451. So it's going to be 3.8451. So that will be my answer. Again, I split 7,000 into 7 and 1,000. For 1,000, log of that is 3. Log of 7, I computed from the table, and then I added them.
In the classroom to ensure students are in proper uniform attire. Thank you.
The third part here, 0.00006, I changed that into 6 times 10 to the power -5, and then I again, using this property, I split them. So I will have log of 10 exponent -5 plus log of 6. Okay, so 10 here again I have -5 plus log of 6 is 0.7782. So when I do the simple calculation, so I will have, just a minute. So I will subtract -5 from 0.7782. I will get -4.2218. Okay. Now I do the last part of example 1, log of 3 times 10 exponent 27. Again, no problem. I just split that into log of 3 plus log of 10 exponent 27. So log of 3 is here 0.4771, and log of 27 is simply 27, 10 exponent 27, and then when I add them, I will have 27.4771. That will be my answer. Now let's do the second example. It says calculate the following values using the table below. Log of a product of x and y, xy, is equal to the log of x plus log of y. So let's consider this property, which is a very important property, and solve these problems. Okay, we again have a table of log from log of 1 to log of 9. So here we have log of 2 plus log of 4. So what we do is it equal to log of 8? Let's check that. So log of 2 plus log of 4 means log of 2 times 4, and that is equal to log of 8. Okay. Now, If you do it the other way, then you will have to write down the value of log of 2. So 0.3010. And what is the log for 4? 0.6021 plus 0.6021. So when we add them, then we will have plus 0.6021. We will have 0.9031, 0.9031. And if you look at it here, it's the same as log of 8. So yes, we can confirm that as well. Now, the second part, log of 2 plus log of 6 is equal to what? So we will again write it as log of 2 times 6, and it should be equal to log of 12. But to have an answer, we will simply write down log of 2 is 0.3010, and then log of 6 is 0.7782. Okay, so when we add them, then 0.301 plus 0.7782, we will get to the 1.0792. 1.0792. Okay. Uh, since we have values only until 9, so log of 12 we can calculate from using calculator, and then we can confirm that as well. So log of 3 plus log of 4 is the same as log of 3 times 4, and that is log of 3 is 0.4771, and log of 4 is 0.6021. So when we add them, we will get 1.0792. So you can see that it is equal to log of 12. So whether you have 4 times 3 or you have 2 times 6, the value of the log being log of 12 is the same in both cases. Now the last problem for the example 2, log of 6 plus log of 6, we can write this as 2 log of 6 basically. Okay, so now log of 6 is 0.7782. So 2 times 0.7782. So we'll get 1.5564. Okay, and if you could write these together, then it would be log of 6 times 6, that is equal to log of 36. Okay, but if you look for the numerical answer, that's what we are getting, so that is okay. Example 3 says show that log of x squared is equal to 2 log of x. Okay, so if we have log of x squared, then we can write this as log of x multiplied with x. So x times x is x squared, and once we have that, then using the log property we can have log of x plus log of x. Okay, now log of x plus log of x is the same basically, so we can have 2 log of x. So we can say that yes, we can prove it, log of x squared is equal to 2 log of x. Okay, example number 4, use the table above to compute the following: log of 14. So we don't have 14 here, we write log of 14 as the product of 2 and 7. So we will have log of 2 plus log of 7. So log of 2 is 0.3010 and log of 7 is 0.8451. Okay, so when we add them together, let's see what we get. 0.3010 plus 0.8451, 1.1461. 1.1461. That is our answer. Also, the same way we do log of 35 as log of 5 multiplied by 7, because 5 times 7 is 35. Then we will write this as log of 5 plus log of 7. Log of 5 is 0.6990 and log of 7 is 0.8451. So when we add these, we get 1.5441. So 1.5441 is my log of 35. Okay. Uh, all I need to do is I need to make use of this table here, all the values given, and then split the number into in terms of these factors and then solve it. So now we do log of 72. Log of 72 I can break down as 9 times 8. Okay, so let me write this as log of 8 multiplied by 9. Then it's going to be log of 8 plus log of 9, and I have both of these values from the table. Log of 8 is, you can see here, 0.9031, and log of 9 is 0.9542, and when I add them, I end up with 1.8573. So 1.8573. That will be my log of 72. Another problem, part example 4, the last part, log of 120. So this should be D and this should be C. So I can again rewrite this as log of 12 times 10, but since 12 is also not there, so I can write 3 times 4. So 3 times 4 times 10. 3 times 4 is 12, and 12 times 10 is 120. So log x, y, z, I can split as log of x, log of 3, plus log of y, log of 4, plus log of 10. Okay, so now log of 3 is 0.4771, log of 4 is 0.6021, and then I will have log of 10 as 1. So 0.4771 plus 0.6021. So my answer is 2.0792. So 2.0792. That will be my log of 120. Now let's go to the next problem, which says use the logarithm tables and rules to estimate the following. Log of 2100. So now, again, no big deal. I will change log of 2100 into log of 100 times 21. 21, I can write 3 times 7. So the next step, I will separate them. 100 will become 10 squared. So log of 10 squared plus log of 3 plus log of 7. Okay, so that way log of 10 power 2 is 2, log of 3 and log of 7. You can see we have 0.4771 and 0.8451. So we will write here 0.4771 plus 0.8451. So all I need to do is in the end add them. So 2 plus 0.4771 plus 0.8451. So 3.3222, 3.3222. That will be my answer. So in all of these problems, whatever is the number, you change that number into the product of its factors, and then those factors we have their log values listed in the table. So we use those values and we calculate our log finally. Okay, now let's do the second part, which is log of 1 upon 640. Okay, so first of all, when we do that, uh, we again will certainly make use of the tables. So to make sure that you have that table in front of you, I will just put this table here. Just 1 minute. So let's have this table here off. Yeah, this is the table. Okay. So now first of all, I need to bring this up. So when I bring this up, I will have a negative sign. So negative log of 640. 640 I can write as 8 squared. So I will write this as negative log of 8 squared times 10. So it's going to be negative 2 log of 8 and negative log of 10. Okay, so log of 8 is 0.9031. So negative 2 times 0.9031, negative log 10 exponent 1 is basically 1. So my answer will be if I multiply 0.9031 with negative 2, and then I will have, so negative 2.8062. So negative 2.8062. That is my answer. Log of 42, and then we have 6 zeros. So we write this as log of 6 times 7. So 6 times 7 times 10 exponent 6. Then we will break it down into log of 6 plus log of 7 plus log of 10 exponent 6. Okay, so from the table I had shown you earlier, log of 6 is 0.7782, log of 7 is 0.8451, and log of 10 exponent 6 is basically 6. So this log base 10 and this base 10 will cancel each other out. I will have this answer. Then I can just add these numbers. So my answer is 7.6233. 7.6233. So that's going to be my final answer. And let's do the last problem. So of the teacher model. it says use properties of logarithms to show that log of 1 upon 2 negative 1 upon 3 plus log of 2 is equal to negative log of 3. So let's go with the left hand side. So we'll see if that is equal to the right hand side or not. So our left hand side is log of 1 upon 2 negative 1 upon 3 plus log of 2. So first of all, let's take care of this arithmetic. So if we have 1 upon 2, we need to have the common denominator. So we multiply and divide with 3. And if we have 1 upon 3, we multiply and divide with 2. So we leave it as log of 2 here. So in the next step, we will have log of 3 times 1 is 3, and 2 times 1 is 2, and then 3 times 2 is 6. So we will have 3 negative 2 is 1. So log of 1 over 6 plus log of 2. Now this 1 over 6, we can bring it up. So we will only have a negative sign coming out, and it's going to be log of 6 plus log of 2. And this log of 6 is basically 2 times 3. So negative log of 2 multiplied with 3 plus log of 2. So this we can again separate. We'll have negative log of 2, negative log of 3, and then we'll have plus log of 2. So this log of 2 is just coming along without any further simplification as log of 2. This part we are modifying in every step, and we end up where we have log of 2 and log of negative log of 2, so they cancel each other out, and we will have negative log of 3.
Attention teachers, please pause to do a quick safety check. Check that students are properly wearing masks and ensure students are social distancing. Thank you.
So now at this point, if you look carefully, this log of negative log of 3 is the same as this. So we can say that is our right hand side. So we can prove that this expression is the same as this expression. So our left hand side and right hand side are the same. So you can see this is my final answer. So we can prove this as correct. So with that, I'll stop now, and I'll just give you a glimpse of the problems from independent practice. We have a table where we have values of 2, 3, 5, 7, 11, and 13, as well as their logarithms given in the table, and we need to simplify these numbers. We need to find the logarithm of these numbers by writing them as the product of some of these numbers for which the log value is given. So we'll use this table to find the final answer. So you can always consult the teacher model and the way I have solved the problems, and then you can go ahead and complete the this independent practice. There are quite a few problems, so you will do this next. So with that, I'll stop here, and you should go ahead and start working on it. Thank you.